Time for some homework questions regarding confidence intervals. Here's your first question. We'll call this one 55. I'll go ahead and give you a second to read through that. Think about it. You're looking for the sample size to fit these conditions. So at this point, hit pause, and then I'll start moving that green box away, and you'll be able to see your answer, and I'll talk about it. Margin of error is either z star times standard deviation over the square root of n, or t star times s, the sample standard deviation over the square root of n. When you need to use z star or t star, let's think about the difference here. If I know the population's standard deviation, I would be using z stars. If I'm going to estimate the population standard deviation through the use of the sample standard deviation, I would be using t star. They tell me the body mass index BMI of all American young women is believed to follow a normal distribution, and they give me a standard deviation of 7.5. So they're giving me the standard deviation of the population. This tells me that I should use z stars. So I'm going to set the z star formula equal to the margin of error that I'm looking for. The 99% confidence interval that would have a z star directly above that on this chart from the back of your book there is 2.576. So keep in mind that 2.576 is a z star, not a t star, because I know the population standard deviation. Set that equal to the standard deviation over the square root of n. Some fancy algebra with cross multiplying here, and you will get your sample size of 374. This next question is going to be a little bit of practice on just utilizing the t-star chart or the t distributions. So for these two options, A and B, go ahead and pause. Tell me what these t-star values would be under these settings. Okay, answer time. Looking at the table of the t distributions, if question A, 95% confidence interval, I find 95% at the very bottom, and I have an observation of a sample size of 10. Subtract 1, that gives me my degrees of freedom of 9. So I find 95 at the bottom of the page, I find 9 on the left-hand column of the page, I crisscross my fingers, and I should have the following t-star. Same process for question B, 99 at the bottom, 19 on the left for 19 degrees of freedom, and you get the following t-star. Question 59, I want to know the standard error of the mean. You will need your formula for standard error in this one, and then give me an interpretation in context of this question. Standard error of the mean, formula for that would be s of x over the square root of n. Your sample standard deviation over the square root of the sample size. In this case, 9.3 divided by the square root of 27. And you get the following. Question 63. I want the 95% confidence interval for the mean fuel efficiency for this vehicle. And while you're at it, please check your conditions that allow you to do this process. One of the conditions that you need to check for is that you have a simple random sample. The last sentence of the first paragraph says that. Here are the miles per gallon values for a random sample of 20 of these records. The next thing that you need to check is to make sure that your data is normal. That can most easily be done by looking at a histogram. I plot the miles per gallon on the x-axis and how often did they occur on the y-axis. And I can see for the most part that this is fairly normal. Maybe I have a spike at 15.5, but I don't think it's anything out of the ordinary where I would not be able to do a confidence interval. Your confidence interval for 95% is going to come from the formula x bar plus or minus t star times s of x over top of the square root of n, s of x being the sample standard deviation. Plugging in everything, you have the following. The average of all of these 20 scores is 18.48. The standard deviation of all of these 20 scores is 3.116. Your sample size is 20, and the 2.093 comes from the t distributions. You find 95% at the bottom of the page. You scroll up to 19 degrees of freedom. Crisscrossing your fingers at 19 and 95 gives you 2.093. Then your final calculations, 17.022 and 19.938. And please don't forget your sentence. We're 95% confident, yada yada, you can read the rest. Question 61. We're going to do a little working backwards here to find the sample standard deviation, and then give me an explanation on why this would not be a confidence interval. I'll give you a second to think about this one. Standard error is the sample standard deviation divided by the square root of the sample size. So S of x over root n. And we know that that equals 19.03. So I can set that equal to 19.03, set equal to S of x over the square root of 23, and then just use some algebra to solve for the standard deviation of the sample. In doing that, I'll get 91.26. And then question B. Why is this not a confidence interval? Well, because they left out the t star. You would also have to multiply by the critical value. Last question. I want the 99% confidence interval to estimate the mean percent change in BMC. And then based on your interval, you think we got good evidence here to suggest that the average nursing mothers lose bone mineral? Now, I want you to think about that without doing the significance test. Just a heads up, when you're doing your confidence interval, keep all of these numbers in terms of percents. For example, the 2.506%, don't turn that into a decimal. Just leave it as 2.506. And here's your last answer. The mean was given to you, negative 3.587, plus or minus t star. Now, for t star of 99% confidence, when we find 99% confidence at the bottom, and I scroll up, the sample size was a 47. I have 46 degrees of freedom. 46 is not an option. It jumps from 40 to 50 on degrees of freedom on the left of the table. So what you need to do is round down to 40. You're rounding down to avoid making any types of type 1 errors. Now, type 1 error usually goes for a significance test, but by doing that, you're actually giving yourself just a little bit bigger margin of error. So 99% at the bottom of the book, and then using degree of freedom 40 gives me a t star of 2.704. Plugging in the rest of my numbers, they gave me the sample standard deviation 2.506 divided by the square root of the sample size yields me the following interval. And my sentence, I'm 99% confident that the interval ranges from A to B. Your answer for question B, do these data give good evidence? I'm going to have to say, yeah, they do give good evidence. The entire interval is only negative numbers, negative 4.5 to negative 2.6 roughly. So if it's negative, that means there was a loss. So I'm quite confident that there is some bone loss in this situation. And that wraps it up. Hopefully you had a chance to go through those, and that was helpful. I'll see you next time.